Okay, test this Thursday. The web work is up. Work on that. Start working on it if you haven't already. You've got to do it in several sittings. You can't do that all at once. And then there's the outline too, the comprehensive list of skills and concepts that you need to know for the exam. So it's all posted on Blackboard. Exam Thursday. Okay, so we were talking about polynomials, and we left it off with end behavior, which is we're given an equation. We want to know like what's happening way out on the right end of the graph, and so that's x becoming very large positive, and what's happening at the end on the left end, where x is very large negative. And we said that that had to do with the leading term. That's where we left off last time. So end behavior. So by end, we mean the ends of the graph. The right end and the left end. Okay, that's what I mean by end behavior. And this is determined by the leading term, and we talked about why. Because if you picked a really big number here, so here's an example. X cubed plus 4x squared minus 6x. So you pick a really big number, like a trillion. So if we put a trillion into there, how does it compare with putting a trillion into there? How does a trillion cubed compare to a trillion squared? Are they close? Are those about the same? They one off because the exponent's one off? Are they one off? So by how many times greater is this one than this? A trillion times greater. And that's what we're talking about, really big values of x. Okay, so then the bigger the value of x gets, the more this is bigger than that. So whatever the value of x is, it's that many times greater than that. So in the grand scheme of things, everything else looks like 0 compared to the leading term when x gets very, very large. So as x goes to infinity, this is virtually 0, and so is this. Why? Because this is at least a trillion times greater, or 100 trillion times greater, or even bigger than that, right? So it's the biggest value of x you can imagine. This will always be that many times greater, at least that many times greater than all the rest. So it's like the rest of the terms disappear. So when we look at the end behavior, we're looking at the leading term. So here's what we do. As x goes to infinity, then we ask that whole term. Will it be a large positive value or a large negative value? X cubed. So a very large number, positive number, cubed. Very large positive or very large negative. There's only two choices, right? It can only go, y could go up to positive infinity or y could go down to negative infinity. So positive, right? So if you cube a really big positive number, you're going to get a really big positive number. Okay? And then we say, so now that's the right end. That's the right end of the graph. And then we look at as x goes to negative infinity, meaning way out to the left, very large negative number, we ask x cubed. Is that going to be a really large negative number or a really large positive number? I heard both, positive or negative. Negative. Yeah, when you cube something, when you cube a negative, you're going to end up, you're multiplying it together an odd number of times, and you're going to get negative. So our end behavior here is like x cubed, which when you go way out to the right, it goes up. And when you go way out to the left, it goes down. So So this, when we talk about end behavior, this is what we're saying. The right end, it's going to go up, and to the left, it's going to go down. And we get that by looking at the leading term. Okay, so let's take a look at that. So what I'm going to do is let's graph. We'll graph both this polynomial, it'll be red, and then just the leading term, x cubed, will be blue. So like we said, they're the same, right? Can you see it? No, they look totally different, right? What's the problem? Why? So we thought, oh, this is going to be like this, right? Why are they totally different? Yeah.
Because we only compared the behavior, but we didn't compare the entire function.
Yeah, this is like these are small values of x, right? 1, 2, 3, 4, 5. All I'm showing here is like what's called the middle of the graph, not the ends. The ends are for very large x values and very large negative x values. So we got to change our scale here. So zoom out a little bit. Oops. Sorry. There we go. Okay, so let's get a better view of it here. So now I'm starting to zoom out on this to see larger and larger values of x. So this is just 100, right? So this is just now 100 to negative 100. And already within that span, they're already looking a lot alike. And now I get to about okay, so here I'm at 20,000 and 30,000. And it's the same graph. You can't tell the difference. Right? So this is just showing that the leading term, so a polynomial is just like its leading term when you start looking at really large values of x. I'm looking here in the 10,000s. 10,000s. Okay? Again, you look in the middle, though, totally different. See? So now we're back in the middle where the values of x are small, close to 0. Totally different. So it's only for the ends, only for large values of x that it applies. Anybody have a question on that? Okay, so we need some more practice at figuring out the end behavior. So that was on page 199, that one. So go to page 199, there's a couple more there. Number 7. Number 7 on page 199. And this ends up being actually here. These two right here below are 7. This is 7a. And then 7 is a 7b, yeah. So I have a different screen, but these two problems are the same. This is 7a. And this is 7b. Is that right? Yeah, they're named differently. So the name of the function is different, but the rule is the same. Is the rule the same for A and B? Okay. So work on those two first. So work on 7a and 7b. And what are you working on? You're finding the end behavior. Okay, so you're finding the leading term. And then you're asking what happens when x gets very real. And here's the deal with this. First you want to look at this part. First look at this, and then consider, then consider what it's being multiplied by. So there's two things to look at. So first look at just the x portion and the exponent, and then consider what's being multiplied by to make your final conclusion about when x gets very large positive, what will y do? And when x gets very, very large negative, what will y do? Okay. So notice the leading term wasn't first on this one. You can change the order. Okay, so the leading term is the highest power of x. Okay, so work on those, and I'll start roll. And then when they're done with those two, they can go on and do these two. They're not in the book, though. Okay, right end. First one. Right end, meaning large positive values for x. So what do we do? So first you look at x to the fourth. Large positive or large negative? Large positive, but then it's getting multiplied by -2. Conclusion? Down. Negative. It's going to go down when you go way out to the right. So way out to the right, it's going to go down. Everyone get it? All right, what about way out to the left? Okay, let's talk it through. X to the fourth. So if x is a very large negative, first you look at x to the fourth. Positive or negative? Positive because it's an even exponent, right? A negative multiplied together 4 times makes positive, but then we still multiply by negative again. Conclusion?
Negative or down.
Down. So it will do the exact same thing as -2x to the fourth, which is go down. It goes down to the right, it goes down to the left. Negative infinity. Questions on that one? Okay, part B. So this is a little different because this is the factored form. So we got to get the leading term out of this. So when you multiply out to get the terms, what you do is you take, every term is going to be taking one term from each factor. So if you want the leading term, if you want the biggest power of x, you're going to go through and you're going to take the biggest power of x from each one to figure out what that leading term is. So come along here, it's going to be -7. What's the largest power of x there? X. Next one. X squared. So when you're computing all these terms, you're going along, you're always picking one out of every factor. You pick one out of every factor. That term that has the largest power of x is when you pick the largest power of x from each factor. So you're going to pick -7, x, and x squared, which gives you -7,
X cubed.
x cubed. Okay, so now we got the leading term. So you can get the leading term without having to multiply the whole thing out. You just go through each factor and pick the largest term of x. Okay, so now -7 x cubed. As we go out to the right, large positive values. Again, you got to break this up. Look at that first, and then look at this. Okay? So, way out to the right, look at x cubed. Large positive values of x will mean what for x cubed?
At first it means y will be, we're going up.
So yeah, so if you take a large value of x and you cube it, you're going to get a large positive value of x. But then, we multiply by negative.
So it's going to go down.
It's going to go down, negative infinity. That's at the right. The left end, large negative values of x.
Since x is cubed, so it's going to be negative infinity at first, but then it's multiplied by -7. So it's going to be a positive infinity. The graph's going to go up.
Okay, did you hear what Travis said? So, for large negative values of x, what does x cubed do? Becomes large positive or large negative? Negative, because it's an odd exponent. But then, we've got a large negative, and we're going to multiply it by negative. So it's going to go up to the left. So always start with the x term and figure out whether that will be positive or negative, and then look to see if you're multiplying by a coefficient that's negative or positive. Okay, so just really briefly, this 7b, that if we were to sketch that just the end behavior, as we went way out to the right, it's going to head down to negative infinity. As we go way out to the left, large negative values of x, y is going to go up to positive infinity. So this is the end behavior of this graph. Just like negative 7x cubed at the ends. Okay, does it make sense? Anybody have a question? And there was another thing we got from the expanded form really quickly, like this one here. So what else can we know about the graph very quickly just by looking here at the expanded form? There's one quick thing we can get. I know Joseph knows. Hayden. Okay, the leading term gives us the end behavior, but then there's something else we can get really quickly here. What's that? Chris says the y-intercept. Yeah, 8. So what about the number 8? It gives us a point on the graph. What point? 8, 0? Not 8, 0. 0, 8. And that's the y-intercept. At the y-intercept, that's where x equals 0, not y. Okay? The y-intercept is where x equals 0, not y. If you plug 0 in for x, you get 8 for y. And that's called our y-intercept. Okay, so those are the two things that the expanded form gets us. The leading term gets us the end behavior, and with the expanded form, we can also pretty quickly see what the y-intercept is. So now let's look at this one that's C on my screen up here. And so this is factored form. Okay, and so from factored form, let's practice one more time. Let's get the leading term for h of x. If you didn't already, right now, get the leading term. Can you figure out what the leading term is for this without multiplying the whole thing out? Take 30 seconds and see if you can do it. What would the leading term of this be if it were expanded? Go. Okay, this is the same one I've got here up at the top now. That's the same one. Okay, Julie, did you get the leading term, or do you know how to do it? 3x to the 5th? How did you get that? Okay, so how many powers of x do you get from this one? And then what about this one? It's a little tricky though, but look, that whole thing is squared. So what do you think? So we get x squared, and then we don't really get x from the second one. What do we get from this? Yeah, we get another x squared from that. And from this one? And the last one. Yeah, so you had it perfect, it's just you overlooked the square on that, okay? And so that is? And from that we can get the end behavior. Okay, as x gets very, very large positive, is y going to be positive or negative?
Positive.
Positive, right? As x gets very, very large negative, looking at this, will y get very large positive or negative?
Positive.
Yeah, so with x to the 6th, a very large negative will become positive because you're multiplying it together an even number of times. Then we keep it positive by multiplying by 3. So end behavior is like this. Up to the right, up to the left. Okay. So now the factored form, so what's missing here? So we haven't talked anything about what's called the middle behavior. Okay, the middle behavior then is what's happening for lower values of x in the middle of the graph. Okay, and that's middle behavior corresponds more to the factored form. Okay, so the first thing is, and you worked in your homework, the factored form easily gives us the roots. Okay, so there's the factors. We'll list those out. And from the factors, we can get the roots. Okay, so first factor is run out of room here. Let's try that again. Okay, so we got the factors, the roots. So the factors are those parts of the expression that are multiplied together. So we got x squared, x plus 3 squared, 3x minus 4, and x plus 1. And each of those factors gives us a root. What is a root? It's a value of x that makes the function 0. So we're asking for the roots. We're asking what value of x would make that factor 0 and therefore the whole function 0. So what's the root for x squared? Okay. What's the root for x plus 3 squared? Angelina. And then 3x minus 4. What x value will make it 0? So if you're not sure, you can go ahead and solve it. Do 3x minus 4 equals 0 and solve for x. And you get 4 over 3. 4/3. Last one. X plus 1 gives a root of -1. So right away we have these values of x that make the function 0. So where will those be on the graph? They're values of x that make y 0. Where will they be on the graph? Right. X-axis. These are x roots are x-intercepts. X-intercepts. All right. So they're where y is 0. That's on the x-axis. So we've got one at 0. Okay. We've got one at -3. And 4/3, which is 1 1/3. Something like that. And then -1. Okay, so you see how right away this is now these factors are helping us determine what's going on in the middle of the graph. Okay, and so then if there are no more roots, when we get to the left of -3, remember our end behavior, where's the graph going to go? Is it going to from here? Is it going to go up or is it going to go down? Yeah, it was what was our leading term? 6x to the 4x to the 6, 3x to the 6th. 3x to the 6th. Okay, so our left end behavior was up. Because there are no more roots over here. It's never going to cross this again. This is the last time it touches the x-axis. So from here, it's got to go up. And then what was our right end behavior? Also up. And it's never going to touch there anymore. So up again, like from there. So the question is, we want more than just the roots. We want more details about this. So let's turn it on. We're going to turn the graph on and take a look at how the graph matches with the formula. Okay, so there our roots were perfect. Okay, we nailed them, and we got that. But the question is, sometimes it's doing different things around the roots, and so we want to try to figure out by looking at the equation, how do we know what it's actually doing around the roots? Okay, so at -3 and 0, it's doing what? It's doing like a bounce, right? It's coming down and it's like bouncing off. But at -1 and 4/3, it just goes on through. So how can we make sense of that looking at the equation? I know Joseph knows. So what is different about at x equals 0 and x equals -3 in the equation? What's that? Did you say it? Alyssa, did you say it? Yeah, they're squared, okay? And so, like x squared. What kind of graph is that? Like a parabola, right? It's a parabola. And what do you see? And that's also x plus 3. What do you see when you look right just in the local area around -3? It looks kind of like a parabola, right? And look at the local area right around x. It looks kind of like a parabola. Now it's going down, but it's fine. Okay. So this is what's called the multiplicity. Okay. So there's another thing we want to put in our table here, and it's called the multiplicities of each factor, and that helps us get the behavior around the roots. So x squared. So the root x squared. What's the multiplicity on that? The multiplicity is the degree. It's 2. What's the multiplicity on x plus 3 squared? 2. What about 3x minus 4? 1 and 1. So it's the power. The power on the factor is called the multiplicity, and that kind of reveals kind of the shape or the behavior of the graph around that root. So multiplicity of 1 is, if 2 is quadratic or parabola, what is 1 like? What kind of, like this to the first power, just by itself, what does it give you? Linear, right? Linear. So this is, 2 is like quadratic, like a parabola. And 1 is like linear. And so look at what's happening at -1 and 1.3. If we were just to look really close there, it just goes straight through like a line. I mean, it is curved, but in that local area, it's pretty straight. And it's even more here. You can see it more here. Just right around 4/3, it's shooting straight through like a line, and that's the relation there is the multiplicity is 1, or the power 1 at that root. Okay, so we've got 4 things that we put all together to analyze the polynomials. We've got the end behavior, we've got the y-intercept, we've got the roots, and now the multiplicities at the roots. And by putting all that together, we can sketch these graphs, or given the graph, we can work backwards and figure out what the equation is. Okay, so we need to practice that. So let's look at okay, so here's one. So here's the graph. Let's see if you can come up with the equation now. So you're going to start with that table. Build this table. So if you've got the roots and the factors and the multiplicity, then you've got what the factors are the things you'll multiply together to get the equation. Okay, so tell me one root. Danny, give me one of the roots. -3. Okay, so if the root is -3, keep going. What's the corresponding factor that would correspond to -3?
X plus 3.
He wants x plus 3. How do you know? So if you were to put -3, you should get 0 in that factor. So if you were to put that root in, you get 0. Do you get 0? Yep, you do. Now, what's the multiplicity? We get that by looking at what's going on around there. Is it like linear? Is it like a parabola? Is it like a cubic shape as it goes through? All right, so what's the multiplicity? 1. So part of our equation is going to be x plus 3 to the first, or just x plus 3. Okay, another root. Mitchell. 1. Okay, tell me the corresponding factor if the root is 1. Good. And what does the multiplicity look like there? 2. It looks like a parabola, so it looks like it's squared. So now we have a start at what the equation might be like. So we're writing this polynomial. We'll call it P, polynomial. So based on what we have so far, let's get a first attempt at the equation. Byron, you're up. Well, based on these factors and these multiplicities, can you give an initial attempt here at the polynomial equation? Okay. Yep. So it's going to be something like that. But notice that if we had some constant multiplied out here, like 8 or -6, all these still things would hold, right? So everything else would still hold if we had a constant there. It would still have, you would still have a root at 1 with multiplicity 2 and a root at -3 with multiplicity 1. So we have to account for that, and we say, okay, there might be some constant there out in front. Why? Because there's a lot of functions that have a root at 1 with multiplicity 2 and a root at -3 with multiplicity 1. And so now we've written them all. Now we've written all of them. So how do we figure out exactly what A is? How can we figure out A? Any ideas? Yeah. Yeah, look, so we got this point right here. What are the coordinates of that point? 0, -1. Because we have 0, -1, that kind of locks in what this A value has to be. If I put 0 in here, I've got to get out the output of -1. Right now, if I put 0 in, what output do I get? If I were to put 0 in here, P of 0 would equal what right now? Yeah, just with this part, it would equal 3, right? Because that would be 1, and that would be 3. But we need the output to be -1. So right now, P of 0, so A times -1 squared times 3 equals 3A. So if we didn't have anything for the A there, our output would be 3. We need the output to be -1. So what value of A then will make the output -1? Just solve this for A, -1/3. Okay, so now we have it. This polynomial is -1/3 x minus 1 squared x plus 3. Did I lose you? Yeah, Travis.
Well, I don't think that I think you were on the right track, but
Thank you. Where did I get off the track?
well, with the x minus 1 squared
Uh-huh.
and times the x plus 3, because
Okay.
when you insert 0,
Mhm.
we would have. Wait, never mind. I saw one.
Okay. So yeah, -1 squared is 1.
Read it correctly.
Okay. So let's see. So we'll reveal the actual graph, and we'll see how we did. That's it. Okay. Does it make sense? Do you follow it? Okay, you can give you a couple to try here. Okay, your turn. Go. Find the equation of the polynomial. Okay, James, you're up. How are we going to get started? Tell me anything. How will we get started on this? Not sure. Horatio, you're next. Okay. Stop right there. Let's do that one. He wants -1. Okay. What's the factor associated with -1? X plus 1. And looking at the graph, what multiplicity do we have? Agree with that? Cool. All right, next. Taz, you're up. Root of 2. Corresponding factor. X minus 2. Multiplicity. Agree? Cool. Byron. Did I just call on you? Yep. You're next on the list. So, what's left? Any more roots? 0. What's the factor? X. Multiplicity? 2. Okay, first attempt at writing it out. Jacob. You're up. X squared, X minus 1, X plus 2. Or sorry, did I mix it up? Yeah, that's right. Okay. Is it right? Are we done? Evan, why not? And how are we going to find that? So really, there's a whole, in terms of what we've done so far, there's like a whole family of functions that have those characteristics, and we need the one, particular one, and how are we going to find that? Plug in, and so is that -4 or 1? -4 is the output, the y value. When x is 1 times 1 squared, 1 plus 1 is 1 minus 2. So we need the output to be -4 when the input is 1. And then what does this all to? -4? No, -2? No, -4. Did I do it wrong? -2. Thank you. Therefore, A equals +2. So our final answer here is let's take a look. Okay, so find the leading term and confirm that it will go up to +infinity as x goes to +infinity, and up to +infinity as x goes to -infinity. So what's the leading term of this? So to get the leading term, you're going to march through every factor and take the biggest power of x that you can. All right, so we're going to get 2x squared, and then times x, and then times x, which equals 2x to the 4th. Okay, and if you analyze it, it'll be up in both directions. Okay, one more. Go. This one has a new element to it. All right, we'll do it together so we can get out of here. Derek, give me a root. -2, corresponding factor. X minus 2. So if we want the factor, so if we put -2 into that, we get 0. So what do we need to have there? So if we plug -2 in, it would make it 0.
X plus 0.
It's going to be plus. Okay, what about the multiplicity? Like a parabola. Like a parabola. Abdulaziz, you're up. Give me another root. 4. Corresponding factor. Multiplicity. 1. Keep going, you're on a roll. Give me another root. 1. Factor. Multiplicity. Okay, yeah, it does go through, but it doesn't go straight through like a line. Do you see this? It does this thing. You know what x cubed looks like? What does x cubed look like? X cubed looks like that, and that's what's happening there. So it's not going straight through the way that does. So it's 3. Last, is there another root? Nope. So x plus 2 squared times x minus 4 times x minus 1 cubed. And what is the y-intercept? 2. So we need to get 2 when x is 0. So if you plug x equals 0 in, you get 2 squared plus -4 plus -1 cubed, and we need to get 2 out of that. So this is 4. Is it 16? Positive 16? A is 1/8. Take a look. Got it. Okay. Study.
Parting words.
Thanksgiving break that Monday. Is it okay if I miss class? I'll be on a plane back.
You get a cushion. Everyone gets like 6 that they can miss
Okay.
as long as you've made most of the classes.
Yeah, I haven't missed one class.
Yep. So everyone's got a cushion.
All right, thank you.
Good.
So I didn't understand how to do a part.
Getting the value of a. So we're looking at when x equals 0, y should be 2. You see? So if we plug 0 into this, right now if we plug 0 into this, we get 4 times -4 times, we get 16 for the output. We need to plug 0 in and get 2 for the output. You see? So we plug in 0. We're saying what value of a would make that whole thing 2, but not 16. So then we need 20. So yeah, so you just set the y value at 2, set the x value at 0, and solve for this coefficient. Make it work. Is it better?
What does x to the power look like if it was passing through? That's a quartic.
Yeah, it's a quartic. So so it's a little different than so x squared. Like this parabola. So the way that quartic is different is it's kind of a little steeper and then flatter and then steeper.
Oh, so it kind of looks more like a horseshoe.
Yeah, well, it'll be steeper away from the root, and it'll hover more at the root.
Okay.
Yeah.
And then
The next one from the fifth on.
It's the same thing. It's the same thing. So this is x cubed. The x fifth will be. This is x cubed. It's the same thing. It'll be steeper. Then it'll hover longer.
And then anything higher than 5. Because would it be the same from now on?
Actually, you should just know up to 3.
Okay. Alright, cool. Yeah, I get it.
Who's next?
Will this be covered on the test on
Yes,
Thursday?
yes, it's on the review sheet and it's in the web work.
Okay, cool.
Yep,
Thank you.
definitely.
I'm just reviewing it. Did you mark me?
Yeah, I got you.
Okay, I wasn't sure.
Yeah, I got you.
Last 2 questions in the written homework, I didn't get them because I didn't find them in YouTube. Like, I didn't-
Which one?
The last 2 questions. In the
Oh,
written
so you can
homework.
email me if you have a question.
Yeah.
But don't worry. So yeah, I know we didn't get to that. So we did. Can you do it now?
Yeah, after today.
Yeah, the key is that you can do it now. But
Alright.
don't worry, you won't be penalized.
And why did we put 0 in here?
Because what is this point right here?
Oh, alright, perfect.
X equals 0, y equals 2. So that's what we need this polynomial to output 2 when we put 0 in.